Hello and welcome back to another video, and in this video we are going to solve the Feb-March 2019 probability and statistics 1, that is 970962. We will be solving 1, 2, 3 and 4th question, and in the next video we will be solving the rest 3 questions, that is 5th, 6th and 7th. So let's start. Here's the question number 1. On each day that Tamer goes to work, he wears either a blue suit with probability 0.6 or gray suit with probability 0.4. If he wears a blue suit, then the probability that he wears red socks is 0.2, and if he wears a gray suit, then the probability that he wears red socks is 0.32. So we can at least draw the tree diagram, rough tree diagram, to make it very much clear. Like, he wears either blue or gray suit, so the probability of this is going to be 0.6, and for gray it is 0.4. and when he wears the blue suit, the probability that red socks he wears is 0.2, and not red, it is going to be of course 0.8. and in the same way, if he wears the gray suit, then the probability that he wears a red socks is 0.32, then not red socks would be of course 0.1 minus this, that is 0.68. So now we can solve any questions related to this. The first one is find the probability that Tamer wears red socks on any particular day that he is at work. So red socks will come by this branch or by this branch. So the probability that he wears red socks is going to be either probability of blue suit and red socks, or means we are going to add it, or it is like probability that he wears a gray suit and red socks, and we can get this probability. It is going to be probability of B into probability of R, that is 0.6 into 0.2 corresponding to this branch, and plus gray and red socks, so it is going to be 0.4 into 0.32, and it is 0.12 plus 4 2s are 8, 4 3s are 12, 0.128, and that's why it become 842. So it is 0.248. we can write in the decimal, in the percentage, or is also it is 24.8%, or we can write in the fraction, also it is going to be 31 over 125. Any of the form would be accepted. So that's this probability that he wears a red socks. Let's do the second part. Here's the second part. Given that Tamer is not wearing red socks at work, find the probability that he is wearing a gray suit. So it's like conditional probability, and we can write it as given that he is not wearing red socks, so R bar, and he is wearing gray suit, so it is going to be gray here. So we have to use the formula, and then we can use the probability, its corresponding probability. So it is going to be G intersection with R bar, not red socks, over probability of not red socks. So we know the denominator, we can get it from the previous part easily, because it's like in the first part we have calculated that what is the probability that he wears a red socks. So what is the probability? That it is going to be 1 minus 0.248. this is the probability that he wears a red socks. And come to this one, probability that he wears a gray suit and not red socks. It's like probability of gray suit, he wears gray suit is 0.4, and intersection means and he is not wearing red socks, it is going to be 1 minus 0.32, that is 0.68, because it is given that when he wears gray suit and then red socks, probability is 0.32, then it means not wearing it, it is going to be 0.68. So this probability is going to be in the denominator we will get it as 0.752, and in the numerator it is going to be 0.272, or we can write in the decimal form or fractional form. It is completely on us. It is 17/47, or if we want to write in the decimal it is going to be 0.3617, so it is 362. That is a probability that he is not wearing red socks even if he is wearing the grey suit. It is given that he is not wearing the red socks at work. So I hope it is clear. Let's do the second question. Here's the question number 2. For 40 values of the variable x, that is n is equal to 40 here, it is given that summation of x minus c whole square is equal to 3099.2, where c is a constant, and the standard deviation of these values of x is 3.2. So if we have the standard deviation, it means we have the variance. So let's write the values which we have now, and we can take it as 40, sigma it is given as 3.2. so it means the variance of this is going to be sigma square, it is 3.2, and we have the formula for variance. First thing, we know that variance of a x plus b, it is going to be a square variance of x. So it means it does not harm if you are adding or subtracting anything here. So what we will do, we will find the variance of x minus c, and that is going to be exactly same as the variance of x, because we are subtracting c. It's like variance of ax, it's like variance of x plus b would be exactly same as variance of x if we take a value as 1. So what is the variance of x minus c, and variance of x, that is going to be same. So sigma square we can write it as same as the variance of x minus c. So, and variance of x minus c is going to be summation of x minus c whole square upon n minus the mean square, that is square of summation of x minus c over n whole square, and that is, we know it is going to be 3099.2 over 40 minus, this is not given, so I'll write it as it is, x minus c over n whole square, and sigma square, that is 3.2 square, if we can solve it is going to be 10 point, or I'll write in the fraction, it is 2256 over 25. So let's solve for this with the square attached till the time we can get a square number. If not, then we can simply solve it. So x minus c over n whole square, I bring it that side, and we got 3099.2 over 40 minus 256 upon 25, and this value is going to be 1681 over 25, and we know it is the square root of 41 over 5. We can calculate it from the calculator. It is square root of this, so we can take the square root both the side, and we will get summation of x minus c over n, that is 40, is equal to 41 over 5, and we can get the value of summation x minus c here by 5 1 ja 5, 5 8 ja, and then 8 into 41, that is 328. So this is the value of summation x minus c. So that's it. Let's do the second part. Here's the second part. Given that c is equal to 50, find the mean of these values of x. So mean values means we know that expectation of ax plus b is a times expectation of x plus b. So if we calculate, so relating this, if we calculate expectation of x minus c, it is going to be similar to expectation of x and minus c separately. So from the first part we know summation of x minus c is 328. So from here we can get the expectation of x minus c. Expectation of x minus c is 328 upon 40, because that is summation of x minus c upon 40, and this would be exactly same as expectation of x minus c, and hence expectation of x would be, that is the mean, I will write mean at the last, expectation of x would be 328 over 40 plus 50. So 328 over 40 plus 50 is 291 over 5. So mean, write mean of these values, or values of x, mean of these values of x is 58.2. 291 upon 5, that is 58.2. That is the mean of the values of x, that is expectation of x, or we can say it is summation of x over n. It is the mean. So I hope it is clear. Let's do the next part. Here is the third question. The time taken in minutes for trains to travel between Alphaton and Beaton are normally distributed with mean, that is mu, 140 and standard deviation, that is sigma, as 12. So we can take the random variable, since it is a time, so we can take t also. In place of x we can take t, and this is normally distributed with mean 140 and sigma is 12, so sigma square is going to be, that is variance is going to be 12 square here. Find the probability that a randomly chosen train will take less than 132 minutes. It is in minutes, so we need to find the probability when t is less than 132. So in the standardized form it would be probability of z less than 132 minus 140 over sigma, that is 12. So it becomes probability of z less than minus 8 over 12. So now we can see from the diagram of normal distribution, it is this, and we know 0.8 minus 8 over 12 is going to be probability of z is less than minus 0.666 and so on. So again 7 I'll write till 4 decimal places, and since it is minus, so it will lie somewhere here. It is minus 0.6667, and we need to find less than that. It means we need to find this area, and we don't know the phi with the negative sign, so we will get the exact same, since it is symmetric, we will get this exact same value 0.667 here, and we can calculate this area, and that is why how we will calculate by 1 minus phi of this. So it is going to be 1 minus phi of 0.6667, and now we can get the values of this from the distribution table, and it is 1 minus 0.7477 from the table, and hence it is going to be 0.2523. This is the probability that the time will be less than 132 minutes. So I hope it is clear. Let's do the second part. Here's the second part. Find the probability that a randomly chosen train takes more than k minutes to travel between Alphaton and Beaton is 0.675. So find the values of k. So let's write it. First of all, probability that time taken is more than k minutes is 0.675. So in the standard form it is going to be probability of z greater than k minus mean, that is 140, over standard deviation, that is 1 to 12. This is 0.675. So now we know that this is going to be greater than, and this is more than 67, that is more than 50%. So we can understand from here that it should be somewhere here at this place, because if we calculate the probability this more than this value, then only it would be more than 6 points, more than 50%, because this is 50%, this is 50%. So from here we can write k minus 140 over 12 as minus phi inverse of 0.675, because it is negative value, that's why it would be minus of this, and this value is minus 0.454 from the table, normal distribution table, and hence k is equal to 12 into 0. Minus 0.454 and plus 140, and this value is going to be 134.552 and all, sorry, it is 2 only, 552. So till 3 significant figure we can get the value of k as 135. So k value is 135 till 3 significant figure. I hope it is clear. Let's do the next question. Here is the question number 4. The random variable x takes the values minus 1, 1, 2 and 3 only. The probability that x takes value x is kx square, where k is constant. So we can write it as probability of x is equal to x as kx square, where x would be minus 1, 1, 2 or 3, only these 4. So the question is draw up the probability distribution table for x in terms of k and then find the value of k. So let's draw the table. So probability distribution table, here we will put x and here its corresponding probability of x is equal to small x. So for x minus 1, 1, 2 and 3, we had k into minus 1 square, that is k into 1 square, that is again k into 2 square, when we put x equal to 2 it is going to be 4k, and k into 3 square, that is 9k. So this is the probability distribution table for x. Now we will find the values of k. So we know that if it is probability distribution, it means sum of all the probabilities for these possible values of x would be 1. So it means k plus 4k plus 9k should be 1, or it is 15k is equal to 1. That's why k would be 1 over 15. So that is the value of k from here, because this is probability distribution, so we'll use the property of that, and though it is like discrete probability distribution. So let's do the second part. Here's the second part. Find expectation of x and variance of that x. So let me bring the tables, because from the table only we can draw this. So here's the table from the first part, and we need to find expectation of x. So expectation of x is, we know that it is going to be summation of x into its corresponding probability. So it means minus 1 into k, that is 1 over 15, we know from the first part, plus 1 into its corresponding probability, that is k, that is 1 over 15, plus 2 into 4k, that is 4 upon 15, plus 3 into 9k, that is 9 upon 15. So it become this minus 1 plus 1 cancel, and 4 2s are 8, plus 3 9s are 27, and plus 8 is 35. So it is 35 by 15, or by dividing by 5 it is 7 by 3. So expectation of x is 7 by 3, and for the variance of x we need to find the expectation of x square. So it is again summation of x square and its corresponding probability, and it is going to be minus 1 square, 1 into 1 over 15, plus 1 square, that is 1 into 1 over 15 again, and then 2 square, that is 4 into 4k, that is 4 over 15, plus 3 square, that is 9 into 9k, that is 9 over 15. So if we'll solve, it is going to be 1 1, 4 4s are 16, and 9 9s are 81. So it is going to be 97 plus 2 99. So it is 99 over 15. So now if we have expectation of x square and expectation of x both, so we can find variance of x by simply subtracting the expectation of x square. This is the formula is expectation of x square minus square of expectation of x, and both the values are here, that is 99 over 15 minus 7 by 3 square, that is 49 by 9, and it is going to be 99 over 15 minus 49 over 9, it is going to be 52 over 45, or we can write in the decimal as well, it is going to be 1.555 and so on, so it is 1.16 till 3 decimal places. So that's it for this video, and we'll be solving the last 3 questions, that is 5th, 6th and 7th in the next video. Till then, thank you so much.